Alright, after much searching I found another resistor of the same value, same type. So we now have 1, 2 and 3. And after putting the scope across this one, I think I'm starting to see what's going on here, and it is looking good. First up, I want to calibrate our scope. Make sure that is correct. I'm set on our 0.5 volt output, 0.5 on the divisions, and we are on 10 microseconds on our time divisions. So just to make sure our scope is calibrated correctly, which it seems to be. The dark line you can see underneath is the shadow, because I've got the light bulb hanging right here trying to get everything clear. But that is the 0 volt line. That is in line with these pink marks here. And that pink mark there is of course the center line. Now we'll hold the camera still throughout this video so you can get some clear screenshots. My camera is cactus, so I'm going to have to put up with this. Alright, so we know that's fine. We're now going to turn to the 0.1. Once again, zero our scope in. Right there. Okay, so we are coming from the positive out into this resistor. Now, this is almost getting foolproof, that I'm aware of. Anything that's going into this circuit has to pass through this resistor, both the high and low pulses. The output has to pass through these two resistors to get to the two LEDs. So we are simply going to measure the voltage and time across that resistance, and the voltage and time across that resistance. Of course our time factor will remain the same because we do not change that throughout the test. So I will turn it on now, and I will hook up the scope across our input resistor. And I have measured all these resistors using the same meter, 4.7, 4.7, 4.8 ohms. Okay, so we're hooked up across there, we are zeroed in, and as it turns out we've managed to get each pulse in between our time divisions, which is very good. So I'll get it in and hold it steady as I can, so you can get a screenshot of that. Like I said, the dark dotted line on the bottom is the shadow from the light. I'm sure you'll be able to see that. So there we can see we are coming up each time the pulse comes on. We're hitting about 0.2 volts, dropping down to about 0.1 volt across the duration of that pulse. And then on the negative pulse we're just doing the same. There's a peak when it fires up at 0.2 volts, and then it levels off at 0.1 volt for the duration of that pulse. And it's my guess that that peak is the quick pulse of current that is needed to crank this coil up. But that is nothing to what we're getting back, as you will see very shortly. Okay, so now I'm going to take our probe and I'm going to put the ground on the centre pin, and we are going to go onto the negative side, or the low side pulse first, which is driving the green LED, and Yes, the meter is back to front, but I want to keep it there because I want to keep that ground in place. I probably could have swapped it around here, but you will see what's happening anyway. Now, already you can see here our 0 volt line, of course. We get our pulse coming through. Now this peaks at 0.3 volts, drops down to 0.2 and then tapers off. As you can see, if I adjust the position slightly, the pulse is 10 microseconds. So once again, I'll hold the camera still so you can get a screenshot if you wish. I wish to, because I want to get some pictures of this. That was what we have on one output of the circuit. But as you'll see shortly, it's not 0.2 of a volt, and I'll show you why. So if we just keep in mind here that this pulse here is on the left side of the centre line, on that first division is where it pulses up and then tapers off to the centre line, and you'll need to know that for what we're going to see next. I'll now take our probe and put it on the other output, and that is what we have there. You can see on top of the current or the voltage we had on our negative pulse, we get the same as our input when it drops down, peaks at 0.2 volts and levels up to about 0.1 volt and goes across, but it continues on the negative side of that pulse that should be here. So the difference has now become nearly 0.3 volts between that pulse. So once again, I'll hold the camera as still as I can so we can get a screenshot of that. Now there's a good reason that we have that waveform right there, and that reason is because one side of this coil is going to ground, the other side of the coil I have got going to the high side, which in this case is actually the low side. So the current is still draining out of that coil when the other pulse fires up, which is giving it a bigger potential difference in voltage across that resistor on the bottom side of the pulse. So that's how that's working, and that seems to be working quite fine as far as I'm concerned so far. Like I said, identical resistors, 4.7, 4.7, 4.8 ohms, and of course our LEDs, our two diodes, which I'm not doing anymore because I've bridged the two inputs to run the single resistor into the system. Okay, so I guess would like some comments on this, and see where we go from there. Oh, there was one other thing. I measured the capacitance of this coil, and it's 49.47 pictofarads. Now every other air coil I measured, standard form, has nothing, so that's pretty interesting in itself. And just to correct, I said there was a steel washer in the middle there. I actually used a copper washer, not steel, so non-magnetic. And that's pretty much it. That's where we're at. So let us know what you think about that, guys, but I think we may have something useful here. Cheers.